The universe, a vast place. No one knows what it's made of. Some people think it's cheese, some people think it's nothing. The Greeks thought it was made out of atoms. In the 19th and 20th centuries, people did surmise that the universe was made out of atoms. But they took it a step further. Instead of the universe being made of just atoms, they were made out of protons, electrons, and neutrons, the three subatomic particles. People thought these were the fundamental particles, but this changed quickly. In 1968, the peeps at Stanford University discovered a different particle that's smaller than either the proton or neutron that makes it up. Physics has been broken. But scientists being scientists are used to this kind of stuff, and they named this new, smaller than subatomic particle, a quark. However, the quark is not just one little particle. There are different kinds of quarks. Like how there are different kinds of gamers. But gamers are cool, so we'll leave that slide. There are two kinds of quarks that are pretty important, the up and down quark. There are other kinds of quarks, we're going to talk about them later. These up and down quarks, I know they're so creatively named, make up protons and neutrons. Two up quarks and a down quark make up a proton. Fun. While two down quarks and an up quark make up a neutron. Recipes, am I right? In the 50s, physicists discovered another particle called the neutrino. The neutrino is kind of like the assassins from Assassin's Creed, stealthy and you can't see them, and they could pass through walls. Cool superpower, right? Which is kind of, okay, since billions of neutrinos are passing through your body right now at this second as you're watching my video. But no worries, you're not gonna die or anything. In the glorious decade of the 1930s, scientists discovered the muon. The muon, surprisingly, isn't some kind of special particle destined to change the world or not. It was basically an electron, but heavier. To put this into perspective, you before the quarantine was an electron. You during and after the quarantine are muon. I just call you fat, and I think y'all. Physicists have discovered other particles using glorious technology. They have tau, T-A-U, which is basically obese electron. Then there is muon neutrino and tau neutrino, also obese neutrino and slightly flat neutrino. And there are 4 different kinds of quarks: charm, strange, bottom, and top. The naming department there is so cool. I wanted that room for oddballs like me. And as if the whole particle shebang wasn't already wacky and wild enough, and we haven't even gotten into quantum physics yet, every particle also has an antiparticle. A particle which is the reverse charge of a regular particle. So if you take a little electron, right? Its antiparticle is the positron. And if those two meet, kaboom's gonna happen. Basically an explosion that is bigger than a nuclear explosion if a negative charge and a positive charge particle meet. These particles are also organized into families of particles. In one family, we have the electron, the OG neutrino, up and down quarks. In the second family, we have the muon, the fat electron, the muon neutrino, the fat neutrino, charm and strange quark. And in the third family, we have obese electron, tau neutrino, obese neutrino, top and bottom quark. These are basically the general gist of particles, but here we go. The universe is full of forces too. You know, they push and pull, people hitting each other, electricity, lightning. Well, all these infinite, or so you think, forces can be organized into 4 fundamental forces. We'll talk about those. You already know gravity. It's pretty familiar to us. It's the force that keeps us not flying into space. Also, we also covered this in 8th grade science, so anyone below the 8th grade, here's a bit review. Gravity is the force that keeps us planted down on the Earth. Our mass is an indicator of how much gravity an object has. The more the mass, the more the gravity. The less the distance, the more the gravity. The electromagnetic force is also pretty familiar. It's basically how every aspect of modern life is running. You have to thank for that. Just how mass increases the potency of the gravitational force, electric charge increases the potency of the electromagnetic force. And light is also an electromagnetic thing too. The two last forces, the strong and weak forces, aren't felt that much on daily life as their potency drastically decreases on all but the subatomic scales. The weak force is responsible for the decay of radioactive materials such as half-lives, and the strong force is responsible for keeping the nucleus together. Each force also has a messenger particle. The electromagnetic force has the photon, which is the base particle of light. So light is actually part of the electromagnetic force. The weak force has a weak gauge boson, the strong force has a gluon, which glues to the nucleus. It's pretty descriptive. And the gravity has a hypothetical particle known as the graviton, which we have not heard of yet. All of them have zero mass. Scientists are trying to find ways to unify these four forces into like a one country thing, but even though quantum physics has unified three forces of electromagnetic, weak and strong, gravity, being the weird kid, decides to act out and not be unified. There are two theories: quantum mechanics unifies the three forces aforementioned, and general relativity, which describes gravity. There is a contender called string theory that might help, but we're not getting into that file right now. It's a night. Anyways, thanks for watching this video, and subscribe if you want to. I'm not gonna force you to do it. Just hope you subscribe and so you can get awesome content every day.